convert CSV to shapefile using GeoPandas. So in this section, we're going to look at how to use GeoPandas to convert CSV files to shapefile and maybe some other formats. So the first thing we need to do is we need to import this is step 0 is import library. So we're gonna import so here we're gonna import pandas. So this is to read in the CSV file. We're gonna import Shapely. So with Shapely we're gonna use, this is just to help us to convert the latitude and longitude values to geometry. And of course we need to import GeoPandas, and we also need a couple of other modules as well, which is request to download data from the internet and OS and globe. So we run that. The next step is we're gonna download data from the internet, and in this step we're going to use Python to download data. So the data is at this location, which is from simplemaps.com statics data world cities basic simple world city. It's a zip file. So in order to download the file, we're gonna create a new function. So this function is called download URL, with the input arguments is URL, say path, and a chunk size. So the URL is the address, URL address of the data file. This can be a CSV file or it can be a zip file. Say path is actually the location that we want to download to in our local disk. So after we run and define this function, we're gonna have a function there. We're gonna define the URL where the location of the data is, and then we define the save path. So for the save path, we're gonna download into our local current working directory. So let's check our current working directory, which is get current working directory. So we are in this location, and if you look in the left here, I have that in this folder is here in data R2 here. So let's delete this. So I got the save path. So the save path is going to be just because I'm in the current working directory, so I just get the file name. To get the file name, I use the os.path.base name, and I get that. So let's try to run this again, and I will show you how it works. Here the URL look like this, and the save path look like this. So it's just getting the name of the save path. Okay. After we got that, we're going to run the download function. So just copy and paste it here and run it. So the download function, the input URLs and the save path. And I'm going to download and run it. It takes about 1 second. And you see on the left here, I got a zip file. So in order to unzip this, I just simply right click on that and choose 7-zip and extract here, or I can use Python to unzip it. So I'm going to show you how I can use Python to unzip it. So the next step is we're going to unzip that using Python. So here I'm going to put it as step 2 here, which is unzip using Python. So in order to unzip it, we need to import zip file. So we need to put it on the beginning here, import zip file, and we need to we're going to use this function. So in zip file, it's going to have a function called zip file, and here we put in the parameter called path to zip file, which is the location to the zip file as zip reference. Then we get that zip reference, we're going to call the function extract all to the directory to extract to, which is we can define later as a local location in our disk. So we're going to define that. The path to zip file is actually just the save path. We can check that the save path is here, which is the location to the zip file. And the directory to extract to, we're going to choose to use the same name with save path, but we're going to eliminate the extension paths, so just -4. We can check it here. So the directory to extract to is actually the same name as the zip file here, but without extension. So we define the location of the zip, we define the location of the folder that we want to extract to, then we can run the zip unzip function now using Python. So we're going to run it. You see on the left here, after running the unzip using Python, we got a folder which include world city CSV file and world city. I'm going to zoom in a little bit to see a world city CSV file and world city XLS file here. So we're going to get back to this. So we done the step of downloading and unzipping. So now we have some data to work with now. So in order to work with that, normally I'm going to open with Excel to check and to see how the data looks like. So we can see that it has a header row here with city name, city RC, latitude and longitude. That's interesting that longitude they put in is NLG like that. We probably edit it to be long like that for convenient for us. And then the country, and then some other information like admin name, capital, population and stuff. So we can say it's CSV UTF-8, comma limited. So just to make sure that the text is in UTF-8, and then save it, override it. Okay, so we are happy with the CSV file and the content of that. So the next step we're going to look at how to create a data frame, a GeoData frame using that CSV file. So we call it step 3, which is create a data frame from a CSV file. So in this step, we're just gonna define the world city is firstly we're gonna use pandas. So we're gonna create a pandas data frame. So you're gonna choose read CSV and we put in the location to the shape file, to the CSV file. So we can define the CSV file location here. So in order to define the CSV file location, one of the very simple ways, just go to the location of the CSV file like in the left here, and you hold the shift key and right click and you choose copy as path here, copy as path like that. Then you come back here and then you paste it into that, but it's pretty long, isn't it? So sometimes I don't like it because it's pretty long. So I can, and then we can read that CSV file, put in the parentheses there, and we can view the first 10 row I think of the data frame. So we get that the first 10 row, no, it's the first 5 row actually, which is pandas. So it is the first 5 row. So you can see that that is the data frame we can read in. We can comment this if we don't like it, and we actually can use different way to define the location of the CSV file. We know that before here we know that we have the directory that we want to extract to, the location of that. So the location of that is going to be just that one, and we can plus with the file name. The file name we know that the file name is world city CSV. So it's just like this, and then we run this again. It seems not working because we need something like this as well. So that is the second way that we can define the CSV location. Let's see, we have another way. We can use os.path.join. This is very common way to define the path for the CSV location. So in the join here, we're going to put in firstly the directory to extract to, and then the name of the file. And for this one, we don't need /, and we can run this again, and we got the same result. Okay. So we now we got a pandas data frame of the data already. So the next step, which is step 4, we're gonna create a geometry column, because this is a pandas data frame, so it doesn't have any geometry column and it doesn't understand the geometry object. So we need in order to create a GeoPandas data frame, we need to create a geometry column, and from that we can create a GeoPandas data frame. Actually, this is a long way, but this helps us to understand more about the GeoPandas data frame, and we can compare with the normal pandas. The difference is just it has one more column, which is geometry column. So now we're going to create that geometry column. So here we're going to create geometry column, and we just name it as geometry. And how to create that, we're going to choose to use list comprehension, where so from the actually sometimes we import from here, it doesn't make sense very much, so maybe we can just cut here, and we're going to cut it there, and we're going to put it there, so it's more convenient. So firstly we need to import point, which is a module from geometry, Shapely geometry. Point is actually a let's run that. So point is, what is point? Point is actually a so it's a class. So point is a class. So inside point you can have like this. You can have it's a point class. So inside point class you can have x, y, z, which is the point value coordinates value. You can have some method, which is x to return the x coordinate, xy to separate array of x and y coordinate values, like this. And what else that we can have from this class? We can even get some kind of area here. So that is the point. So point is actually a class. So when we want to create a new point, we need to put in value for it. So when we put in x and y value, we actually generate a new object called point object, and then we can get that. This is very good example and simple example, and this is a good example to explain how object-oriented programming is applied in Shapely package. Okay, let's get back to our example here. So we understand that point is a class, and we want to create a bunch of new points using that point class, which is point objects. So in order to create that, we just call point, and we put in x, y, and here it's actually x, y like that. If we want to create a new point like 1 and 1, we just create that one, which is a new point, which has that coordinate. And if we call, and then if we need to name it, so name it as point 1, which is that one. Then now we can call a bunch of information from that one. Area, of course, is not fun to get the area of a point, but we can have like x value, we can have xy. Okay, so when we call xy, it's gonna bring an array of the coordinate pair of that point. So that is in the example to understand what is a point object. So in here we're gonna use normally it looks like this, but we're gonna use a zip function to actually zip two columns together into one. So let's make it together like that. We're gonna have because we got the world city here, so we want to get the latitude and the longitude column. To achieve the latitude and long column, you can get dot, and you go to lat, and you're gonna get that full latitude column. You can also get world city and a longitude as well, so you're gonna have that. That's the way you can access latitude and longitude column. But you can also choose world city and then put a square bracket like that and put in lat to get the latitude column, or put in long to get the longitude column. Okay, so now if we're gonna zip latitude and longitude together, we're gonna have a pair of longitude and latitude. Actually, we forget to use the close parenthesis. Okay, we're gonna zip like that, and if we make a loop for kind of xy in, or maybe not xy lat long, we make it long lat in there, and you're gonna print it out long lat like if. Okay, just that, print out long lat, and we're gonna have a pair of coordinate from longitude and latitude, print out that. So that's the way that we can form a pair of coordinates based on latitude and longitude column from a pandas data frame. Let's delete that. So, and in order to do that, we're gonna use list comprehension here. So we're gonna for any long lat in the zip for each pair of coordinates values, longitude and latitude, we're gonna make a point based on that. So that's the way that we create a new list of geometry object using list comprehension based on the longitude column and latitude column. with zip function using the point class that we call the point class from Shapely. Actually, we can create our own point class, but because Shapely already have, so we don't need to create it. So we got that. So geometry. After we run that, this one is not working. So we got geometry, and then we check the geometry type. It should be a list. And then if we print out the first 10 items of that list, we're gonna have something like this. So which is like that. We can maybe for a point in, maybe 4 point in that one. We're gonna print out point. So that is the first 10 points that we just generated from each pair of coordinates value, longitude and latitude. Okay, so we delete this to some space. We done that. Next is we're gonna define the coordinate reference system. So here we're gonna choose WGS84, which have the EPSG is 4326. So we want to check it. We can check that EPSG WGS84, and then we get into there. And when we look at, so WGS84 is actually EPSG 4326 here, and this is a way that we can define that. Define the coordinate system, coordinate reference system, and which is based on this EPSG code. Next step is we're gonna create a geographic data frame based on the geometry list and the coordinate system and the pandas data frame that we just have now. So we can call it step 5, which is create a new GeoPandas data frame. So we call it GeoPDF maybe, and we need to import GeoPandas. So here we're gonna copy down there. Before this, we need to import GeoPandas, and then after we got GeoPandas, which is GPD, we're gonna call the function called GeoDataFrame, and inside that we need to put in the pandas data frame. So if we don't know how to use this function, there's probably a good help here. Okay, so we have some help on GeoDataFrame in module GeoPandas. So GeoDataFrame, which is GeoDataFrame is an object. GeoDataFrame object is a pandas data frame, has a column with geometry. Okay, so in addition to the standard data frame construct argument, you're gonna have that. So let's quickly run down to hopefully have an example as this. So that is GeoPandas data frame. So inside here we need to put in the GeoPandas data frame that we already have, which is WOR CD. There. And then the coordinate system that we just defined, which is CRS is equal to CRS. And the geometry, which is geometry, is equal to geometry. So again, this is the pandas data frame, coordinate system, and the geometry list created using Shapely. Then we can view the first 5 or 10 row of the new GeoPandas data frame. Interesting, which is first 5 rows, similar to pandas. First 5 rows. If we want like 6, we can put in 6 there. So we got 10 rows of the GeoPandas data frame. And if you compare with the normal pandas data frame, you're going to see that we got a geometry column on the right here. It has the type of the geometry and coordinate values for that point. Okay, we're done for that. So now we already have a GeoPandas data frame. So the next step is simple, that we can do something with it. Do some plotting. So step 6 is plot the map if we like. And here is an example of how to do it. So we're gonna plot the GeoPandas data frame using a plot function. So again, if we don't know how to use a plot function, we can help here. GeoDF plot. Sorry, I make a typo. You can see here it have init figure argument, so we can put in an array here to plot it. Looking for some example. So normally to understand the help quickly, we need to get familiar with the order of the help that is written. From the beginning, it's kind of tedious and scary to read this kind of manual. But when we get familiar with it, it's easier because we know where to look for the information. So that's the help for the GeoPDF plot. It's not very helpful from the beginning. So here we're going to choose the marker as a circle, if I'm not mistaken. I think so. And we can set the figure size here as well. Let's make it a little bit smaller, 6 by 6. Then the color may be green if you like, or maybe make it red. And the marker size, just put it at 0.1 or maybe 0. Make it 1. Let's see how it goes. We plot that. So this is the world cities, and if we want to change the green color, we change it to green color like that. If we want to change the marker like this, we can plot it together. So sorry, again, here when we plot like that, we can see that we have something like this here. If we want to eliminate this, we can put in the semicolon at the end of the script, and that one will be disappear. Similar for this one as well. We can plot it using marker as different way. The size maybe 6 by 6 and marker size a bit smaller, and we put the semicolon there, and we got the map of world city from the GeoPandas data frame. Okay, so that we done for that. And the next step is we need to convert to shapefile. That's the main purpose of this video. Step let's say 7. Convert GeoPandas data frame to shapefile. So to do that, it's actually really easy. So we're gonna do GeoPandas data frame, GeoPandas data frame there, and we're gonna choose the function called toFile. It can be to CSV as well if we want to save the GeoPandas again. Let's try it first. Let's try the toFile. We have so many ways to save data out. So let's try to file first, and then we just put a name there, like world city dot shapefile, and we want to write something here. Or if we want, we can create a new folder and write it to a new folder. Maybe we can create a new folder called export. Or we can choose Python to do that for us. So yes, here is new. Make a directory called export. Okay. So after we run that, we got a new export here. Then after we got that, we can put that into export, that one. So we run it. So you got some problem, some warning actually, not the problem, it's warning. But if we check into the folder, we already have the shapefile there. And to show that shapefile, we can use QGIS, and we just grab that shapefile into QGIS, and we have it display in QGIS look like that. And if we open the data frame, we have city, latitude, longitude, and all the information, the ID without geometry. So we can check the coordinate system. In the information here, you can see that the coordinate system, look at here, the coordinate system is EPSG 4326 WG84 geographic coordinate system. So that is the shapefile it generated. So we finish that, and actually we can create export to some other format as well. Convert GeoPandas data frame to other formats. So here, for example, we want to convert it into let's say if we run this again, we're gonna have an arrow like this. So instead of making an arrow like this, we're gonna use to handle that kind of arrow, we're gonna use try, and we're gonna make accept, then just pass, and then run it again. So if it had arrow, it's gonna pass this because it already has the shapefile here. So I think we run it, we normally have error. The next step here, we're gonna try to write to GeoJSON. Okay, so we're gonna try GeoPandas data frame 2, and we see that it have a kind of JSON there. Let's see how it goes. And this name is as or maybe this same here, export, but you know, code JSON. Run it. If we do like that, we tap, gonna have something inside here. So let's keep it and go to gel package. It's not working actually. Actually it's working, but I need to have that the GeoJSON is not the format that I'm working all the time. So we're gonna write it to gel package, and in order to write to gel package, we just name the package, but we want to put in export here, and the layer will be world cities, and the driver is gel package, and we use try and accept to handle the errors. Run that. This works perfectly fine. We go to export folder, and we see that we seem to have something there. Package, no, it's not working. Sometimes it's not working. Okay, so I'm gonna not using that. It's also not working. For some reason it's not working. Okay, I just typed in the wrong gel data frame. That's funny. Okay, so try it again and accept, pass, run it, take a while, has some warning, but hopefully it's still working for us. So we got a package here. So what if I drop it into QGIS? Okay, it's working, and I open the table content and I got everything the same as the input CSV file. So I think that's it. We got shape file and we got GeoPandas. But anyway, before we finish, we're gonna put all the code into one script. Put all code into one script, one cell, and do one run. So we're gonna remove everything there. Then we're gonna do it like we're gonna copy everything. So the first step is we're gonna import library, and we download data. We unzip the data. We create the data frame. Create a pandas data frame. This step should be create a GeoPandas data frame. Got it. We're done for the step with GeoPandas data frame. So we shorten the step. So we make it not this one. Step 4 is create a GeoPandas data frame. So like for 1 is create a geometry column. Then for 2 is define the coordinate reference system. And for 3 is create a gel data frame. That's cool. That's step 3, step 1 here, step 2 here, step 2, 1, 2 here, 3 here, 4 here. And then step 6 is plotting. Just say plot that. Then step 7 is writing by data out to different formats, so we can write it to kind of shape file. So here 7.1 write to shape file. We can have 7.2, which is write to gel package. Okay, and finally it's write to CSV. But before this writing, we need to create a new folder. So it's like 7.0. We create a new export folder, which is os.make directory, and export, just make new export folder. So we have everything in one place now. We can run the script.
So it's gonna take a while to run, but when it finishes,
Okay, so because the original data frame, original CSV file didn't use longitude, but they use this one, which is LNG. So what I'm gonna do is I'm gonna change that to, instead of longitude, which is there, I'm gonna use the LNG and run this again. So it hopefully, okay, we got the plot. We got some warning, that doesn't matter. We check this plot. We have a new World City GPT file CSV. We check it, it's working. We got a gel package, we drop it in QGIS, it's working. We put the shape file in. Sometimes it has some error, but it's also working as well. So the script runs successfully. So we want that into one script. So now we can write this script into a Python script. So how to do that? We're gonna write it. We're gonna do out file, out Python out py file, which is open, and this is CSV to shape GeoPandas .py, and we're gonna choose writing. And of course, py file need to be closed after we use it. And here in py file, we're gonna write it. And what I'm gonna put in is I should R, and then I put in triple quote like that. So what I'm gonna do, I'm gonna just copy everything in here and I put inside that, and I'm gonna run it. Let's see, I get a file there. So I got a file there, and I open that file using Notepad++. Okay, so I got a new Python script here. Python script. So I'm gonna choose to open it with Spider. So in Spider, it's gonna be easier for me to debug and check it. So just to make sure that I'm in the current working folder here, and I'll start running it step by step. I'm gonna got step 1, which is downloading the value. Step 2, which is unzip. Step 3, so it's still working. I'm gonna run this the whole script. I want the whole script. Something interesting. Okay, so after I run that, you see that it plot to maps there. So that's working beautifully, and it export the value there. So that one way I can run that script. I'm gonna delete this again here. I'm gonna test that script. Yeah, actually I need to put it out there. Okay, so I got a Python script there. I'm gonna try to run that script CSV, and what happened? It's working. Is plot the map, it create the export folder, it's create and generate some export data for me. So now when you have a new CSV file, you just put in the input here, and you're gonna have the output shape file for you. That's easy and convenient. I'm gonna close that. That's close that. Here I'm gonna choose command and code, put that, and run that one. Run that one, and I'm gonna run this in terminal. It seems working now. That's fantastic. So that's the way that I can run using Visual Studio Code, and here Anaconda. So that's the way I do.